the next type of cyclone called as what? Temperate cyclones. Temperate cyclones. See, temperate cyclone mechanism wise, it is very simple, right? But otherwise, we have taken so many alternative names for temperate cyclones. Sometimes I told you, temperate cyclones very popularly even in NCERT is called as what? Extratropical cyclones. Otherwise, we also call them as what? Mid-latitudinal cyclones, or sometimes we also call them as what? Frontal cyclones, wave cyclones, and so on. Okay. Now, location-wise, I know where exactly I'll be having this temperate cyclone occurring. Somewhere around what? Mid-latitude. Okay, mid-latitude. And I know the fact that this is the place where I have a climatic feature formed. We call them as what? Front. And you also know what exactly is a front. What do you mean by a front? Boundary of an air mass, you call them as what? Front, right? A feature which separates two extreme types of an air mass, you call them as what? Okay. And I told you that this temperate cyclones can occur both in land as well as in what? Water. Okay. So we'll try to understand this mechanism as such. See, for example, here, I'm talking about a front. N number of times we discussed about this front. Okay. A place where one side I have extremely cold air mass that is coming from polar region, trying to mix with comparatively warm air mass which is coming from what? Subtropical region. To be very precise, one side I have polar wind, another side I have what? Warm westerlies. Both are trying to converge with each other, but so contrasting in nature, they do not readily converge and create a front. And I know the story of it. Right? Warm westerlies being less in density will start climbing over what? The so-called front. And whenever an air mass rises, it will be resulting in what? It will be resulting in what? Somewhere condensation and precipitation. So that's the reason this is one region in the world where rise of an air mass will be perennial, will be happening throughout the year. And that's the case. Condensation and precipitation will also be happening what? Throughout the year. Equatorial region is one region where already we have identified that almost every day it will be precipitating. So this region, somewhere, the region around 60-degree latitude and 70-degree latitude is another region in the world where continuously it will be what? Precipitating, or it will be resulting in what? Rainfall. Okay. Now here, we are going to talk about this front alone. Okay. Maybe the next image, I'll take it for a larger understanding. Okay. Now, my dear friends, what happens whenever I just talk about the creation of a front? Again, I'm insisting the same thing. One side I have cold polar wind, and another side I have what? Warm westerlies trying to merge with each other. Okay. But what happens? Again, they are so contrasting, they do not merge with each other. It forms a front. But still, cold polar wind being heavy in density will try to push this front, say for example, towards the lower latitude as such, because I understand cold polar wind will be somewhere comparatively heavy when it is compared to what? Warm winds. Warm wind, what happens? Instead of pushing this cold air mass, warm wind will start rising above this front as such. So, whenever this cold wind tries to push this front, almost this movement will be creating a wave-like pattern. At one point of time, this front will be somewhere subjected to breakage. Okay. Somewhere this front will get divided, right? And post-division, what happens? This front itself will be going for what? Circulation. The circulation is what we call them as what? Temperate cyclonic circulation. Okay. So very carefully, if I look at it, the entire process, what I see here, I'll be having a creation of a stable front. Because the cold air mass is pushing this stable front, it forms a wave-like structure. And that is the reason the cyclone is also sometimes called as what? Wave cyclone. Okay. At one point of time, this movement or oscillation will be breaking this front. And post-breakage, what happens? This front will be going for circulation. Okay. So every time what I see, I'll be seeing that this front is going for circulation. Maybe another image if I just take it. Okay. So another image, if I'm just taking it, whatever I have seen in the earlier image, right? Instead of three-dimensional, I'm taking only the front and I am representing it. Okay. So what exactly I see here? Maybe the very first image I see that a stable front is created, right? A front is now getting divided into cold front and warm front. So post getting division, this front is going for what? Circulation. Now the question is, let me try to understand this image first. Okay. What do you mean by a front? Okay. Somewhere when I just talk about front is more like what? Boundary of an air mass. For example, assume that it is more like a compound wall between two houses. Okay. Assume that initially I have a common compound wall. One side, one house, and another side, another house. Something like that, right? One side I have cold air mass. Another side I have what? Warm air mass. So what is the boundary of cold air mass is also the boundary of what? Warm air mass. That's what we call them as what? Creation of a stable front. Very carefully, if I look at this image, when I just talk about the universal color coding, my dear friends, right? Normally, we use red for representing what? Warm or hot, right? And blue for representing what? Cold conditions. Now, what I understand here, looking at this image, I find what is the boundary of cold air mass is also the boundary of what? Warm air mass. I do not have any separate classification called as what? Warm front and cold front. That's why I call this front as what? A stable front. Okay, right. Now, here what happens? The stable front is getting oscillated, right? Why exactly this oscillation is resulted? It is all because of what? The further push of this cold front. Okay. Now, here, the third diagram, very carefully, if I look at it, this is the time when the so-called stable front okay. So this is a place or this is the time when so-called the stable front is now getting divided into what? Separately a cold front and warm front. Now what I understand here, what is so stable now? Now it is going for a division. Once it gets divided, it is getting divided into what? Cold front and warm front. Now what do you mean by cold front? If at all a front is a boundary of an air mass, what do you mean by cold front? Boundary of cold air mass, you call them as what? Cold front. And boundary of warm air mass, you call them as what? Warm front. So somewhere I find that this front is getting divided into what? Cold front and warm front. And again, the logic is very simple. Warm front cannot push a cold air mass, but cold front can push what? Warm air mass. So what happens is cold front will keep on pushing this warm air mass, warm air mass, warm air mass, and accordingly it will be going for what? A circulation. The circulation is what I call them as what? Temperate cyclonic circulation. Now comes the question. Whenever this cold front is pushing this warm air mass, what will happen to this warm air mass? Or what may happen to this air mass? Right? Instead of further going to the lower latitudes, what happens? Very easily, this warm air mass will start rising. So as and when it rises, again, that will be resulting in condensation and precipitation. That precipitation, we call them as what? Temperate cyclonic precipitation, right? Now to conclude, if you ask me in simplicity, what is temperate cyclonic circulation? It is all about a front getting divided and going for a circulation. And just a clarity, though I have two types of front, warm front and cold front, which front will be going for a circulation? Cold front will be going for a circulation. For the simple reason, cold front has the ability to push the warm air mass, but not the vice versa. Okay, right. So my dear friends, this image, whatever I have taken as three-dimensional image, the very next slide, only the front alone, I am just taking it. Front alone I am taking, I am just representing this. Okay. So maybe I'll take it as different stages. Kindly note down the stages. I'll explain the minor difference what we have. I'll just explain. So the very first stage of a temperate cyclonic circulation, we call it as frontogenesis. Frontogenesis. Genesis means formation, right? Then what do you mean by frontogenesis? Formation of a front. Okay. Or sometimes I can also rewrite it as either you call them as frontogenesis or creation of a stable front. Or creation of a stable front. See this image, what I'm using here, you have some of the unknown terminologies, but actually speaking, you know it. What is this unknown terminologies? Somewhere you find alphabets written as CP and MT. Any idea what do you mean by this CP? Any intellectual guess? Color coding, I told you, blue means cold, red means warm. What can be CP? Cold pressure. Cold polar. Okay, so close. Okay, fine. Nothing wrong. Even it appears like cold polar, but actually speaking, it is continental polar air mass. Polar is correct. MT means maritime tropical air mass. So what is this CP? What is MT? What is CT? And what is MP? Somewhere, right? The very next topic we'll be discussing. That is what we call them as what? Air mass. Right? So CP here stands for continental polar air mass. And MT stands for maritime tropical air mass. So what is the meaning? The so-called air mass or wind, what I write it as CP, comes from where? It comes from polar region, and it is coming from what? Continental region. Continental means it is coming from land. Polar regions means it is coming from what? Colder region. Very simple. What is the meaning if you ask me? It simply says these are cold and dry winds. Why it is cold? Because it is coming from polar region. Why it is dry? Because it is coming from what? Land. Okay. And if you ask me what is maritime tropical, I would say this is warm and wet winds. Why it is warm? Tropical. Why it is wet? Maritime. So instead of calling it as cold and dry, I can call it as what? Continental polar. Instead of calling it as warm and wet, we'll be calling it as what? Maritime tropical. Okay. The very first stage I have told you. What is the very first stage? It is all about creation of a stable front. Then the second stage, only this diagram, I have just skipped this wave formation. Directly, I have just taken what? Division. The second stage is all about what? Division of stable front. So-called stable front is now getting divided into cold front and warm front. Division of stable front. Okay. The examination, diagrammatic representation is not needed. Drawing diagrams is not needed. Only thing is that if it is not time consuming, go for it. If it is time consuming, kindly avoid it. Right? And the third stage, as already I told you, warm front do not have the ability to move. What is that front which will be moving or circulating? It is the cold front. So what happens is cold front will further move. Okay. It will be moving in the warmer latitudes. Okay. So it will be pushing the warm air mass up in the atmosphere. Right. So whenever there is a movement, right, that movement we call them as what? Quick shift of cold front. Third stage, quick shift of cold front. The fourth stage is formality. Somewhere you can write it, closing down of warm sector. So cold front would have further moved, and the warm air mass, which is now having a ground contact, will be very, very less. Fourth stage, you call them as what? Closing down of warm sector. Stage number 5 is very important. This stage we call them as what? Stage of occlusion. Four is closing down of warm sector. And stage 5 is stage of occlusion. Can you find any major difference between this fourth stage and the fifth stage? The fourth stage, you'll be finding that cold air mass is largely replacing what? Warm air mass. Okay. But if I just talk about the fifth stage, stage of occlusion, very important. This is the stage where the warm front itself is replaced by what? Cold front. Okay. So earlier stage, only warm air mass or warm sector is replaced by cold sector, right? And this is the place, or this is the time when the front itself is partially getting what? Replaced. So stage of occlusion almost, say for example, initiates the stage of dissipation. Almost it marks the end of this temperate cyclonic circulation. Right. So 5 stages you have taken. And the 6th stage, the complete front is replaced. If the complete warm front is replaced by cold front, then this stage we call them as what? Stage of dissipation. Stage of dissipation. Okay. Can I move on? So we have identified 6 stages in total, right? And one more thing, not necessarily that every text I'll be finding the 6 stages given. Some of the text will be giving only 5 stages, right? And whatever it is the case, 4, 3 and 4 is not so important. Whatever the name you want to give it, you give it. Otherwise, it is very, very sequential and important. What is the first stage? It is all about what? Creation of a stable front. All right. What is the second stage? The stable front is getting divided as cold front and warm front. Am I right? Third and fourth is all about the movement of cold front and warm front. Somewhere I said quick shift of cold front, closing down of what? Warm sector, right? And the 5th stage is very, very important. This is what you call them as what? Stage of occlusion. So stage of occlusion, somewhere I said very carefully, if I look at it, this front itself will be replaced by what? Warm front itself will be replaced by what? Cold front. And when the complete warm front is replaced by cold front, that is what we call them as what? Dissipation, or the very end of the cyclone as such. Right? This is all about temperate cyclonic circulation. What are the different stages? Somewhere we have an idea. See, books will be discussing about the weather effectivity induced along the warm sector and cold sector. That much detail and all, it is not needed. What are the different stages, right? Where exactly it happens, that much if you know, that should be more than enough. Even yesterday's class, we have differentiated between what? Tropical and temperate cyclones. Okay. Now here, generally I know that this temperate cyclonic circulation normally occurs in which latitude? Normally somewhere we say around what? 60-degree latitude. That's what we call them as what? Mid latitude. But what I understand, the pressure belts are not static. The pressure belts will be oscillating north and south. Every summers, what happens? For example, I just talk about equatorial low. Even yesterday, I was talking about ITCZ. Right? When I talk about ITCZ, ITCZ is the other name for what? Equatorial low. Okay. Now, when I talk about this ITCZ, my dear friends, normally what happens? ITCZ is okay. When I talk about ITCZ is the other name for what? Equatorial low. Generally, we have an idea that equatorial low should be confined to which latitude? Equatorial region. Low pressure present in equatorial region. I call them as what? Equatorial low. Now I am calling it as ITCZ. Now the question is this so-called equatorial low always confined to equatorial region? Answer is no. Right? Why? Because I understand why equatorial region or equatorial region generally have the development of equatorial low, because I understand equatorial region sun's vertical rays will largely be falling. But I also know the fact that this sun's vertical rays is not always will not be falling in what? Equator. It will be having its own north and south oscillation. For example, I know during summers, by the month of June, July, the sun's vertical rays will be moving towards what? Tropic of Cancer. Okay. So when the sun's vertical rays is moving towards Tropic of Cancer, what happens? This ITCZ will also move towards what? Tropic of Cancer. Right? Similarly, during winters, what will happen? The ITCZ will be moving towards what? South of equator. That is Tropic of Capricorn. So when equatorial low is moving north or south, what will happen to the other pressure belt? Every pressure belt will be moving north in winters, and they'll be moving towards what? South in, excuse me. Every pressure belt will be moving north during what? Summers, and south during what? Winters. Okay. If that is the case, what happens, my dear friends? Even the so-called subpolar low, what generally I have at 60-degree latitude, right? During winter, somewhere it can be descending towards what? South. Okay. So accordingly, what happens when I just talk about, right, largely in winters, what happens? This subpolar low can very easily occur in what? North American region. Okay, North American region. And the same process of stable front getting divided and going for a circulation can also occur. Okay. Now, particularly when I talk about the same phenomena that happens in Gulf of Mexico, one small clarification, even yesterday, Mexico we talked about, right? Mexico is one of the regions we have identified in the 7 regions of what? Tropical cyclones. But very interestingly, Gulf of Mexico is also known for what? Temperate cyclonic circulation. But only thing is that season is different. Okay. The different seasons, Gulf of Mexico experience what? Both tropical as well as what? Temperate cyclonic circulation. So whenever near this Gulf of Mexico region, whenever this all 3 different air masses comes into contact with each other, I've almost taken 3 different air masses. One I call them as what? CP, CT, MT. What is the CP? We have an idea. What is CT? Continental polar. Nothing but what? Cold and dry winds. What is CT? Continental tropical. They are warm and dry winds. What is MT? Maritime tropical. They are warm and wet winds. Almost all types of wind, if at all, if it is coming together, right, in this circulation system, what happens? Gulf of Mexico region alone, right, this different types of air masses coming into contact with each other sometimes results in a weather phenomena called as what? Squall line, right? Almost a region of bad weather effectivity, you call them as what? Squall line. Again, see, whenever I talk about bad weather in climatological parlance, what do you mean by this bad weather? Extreme condition, right? If at all, if I just talk about bad weather again, what all you can associate with this bad weather? Okay, extreme is okay. Okay, I'll put it this way, right? Heavy rainfall. Number 1, heavy rainfall. Maybe I'll call it as a cloud burst. Apart from that, see, bad weather, somewhere again I understand it is associated with what? Cumulonimbus cloud, right? What are the climatic features that is associated with cumulonimbus cloud? Heavy rainfall, you said. Apart from that, very good. Hailstorm, fantastic. Thunder and light. Okay. So somewhere I understand it will be resulting in a squall line. Squall line is a region of bad weather effectivity, and this squall line will be known for what? Heavy precipitation, hailstorm, thunderstorms, etc. We'll verify the same. Okay. So they say Squall line is a quasi-linear convective system, right? Almost say, for example, quasi-linear, it is linear, but not so linear. That's what they say. They are quasi-linear convective system, all associated with what? Rising convection, right? Forget about the technicality. They say this line is associated with what? Thunderstorm, often associated with cold front, etc. That you leave it. Linear thunderstorm structure often contains what? Heavy precipitation, hail, frequent lightning, right? Maybe straight line winds. Okay. So that's the reason with one word, or say, for example, with the simple concept I said, all this put together, we were calling it as what? Bad weather effectivity. Okay. So region of this bad weather effectivity, or the regions of bad weather created on the confluence of the different types of air mass, we call them as what? Squall line. So what I want to tell you, Gulf of Mexico region, very near to Gulf of Mexico region, right? Temperate cyclone, sometimes getting transformed into squall line occurs. But this is not very often. I'll put it this way. Rarely temperate cyclone will develop what? Squall line. Because yesterday, when we are comparing tropical and temperate cyclone, one difference I made it. Tropical cyclone is known for intense weather mechanism, whereas temperate cyclone is known for what? Turn the pages and see the difference. I made a difference between tropical and temperate cyclones. Right. Somewhere I said tropical cyclone is very intense, more intense, whereas temperate cyclone is what? Less intense. Okay. But not always this temperate cyclone is less intense. Sometimes, rare occasion, temperate cyclone may result in the formation of a squall line. Okay. Somewhere, some corner, if you want to write about squall line, kindly write it. A quasi-linear convective system resulted due to the confluence of different contrasting air masses, due to the confluence of different contrasting air masses. Within bracket, what are the different air masses we are talking about? Continental polar, continental tropical, and maritime tropical. Within bracket, you write all these air masses. Within bracket, you write it. Close the bracket. Further, you write, may result in the formation of, sorry, what did I say? Quasi-linear convective system resulted due to, fine, is called as squall line. Is called as squall line. It's called as squall line. Further, you write, temperate cyclonic circulation. Temperate cyclonic circulation rarely results in the formation of squall line. Results in the formation of squall line. And in turn, squall line very rarely gets transformed into tornadoes. Okay. So what I just want to tell you, temperate cyclone, very rarely it will be resulting in the formation of squall line, and squall line very rarely will get transformed into what? Tornadoes. So what I want to tell you, temperate cyclonic circulation getting transformed into tornado is what? Rarest of rare. Okay. It is not very, very common, but very rarely temperate cyclones will be getting transformed into what? Tornadoes. Okay. So all this region, near this Gulf of Mexico region, particularly when I just talk about states like Texas, right, and others, tornadoes are very, very common. And that's the reason, this particular region around this Gulf of Mexico is very popularly called as Tornado Alley. It's called as Tornado Alley. Somewhere note down this terminology and just look for this region, Tornado Alley. So when I talk about this region, Tornado Alley, as I was telling you, the region which is very close to this Gulf of Mexico, where tornadoes are very common. One small clarification, tornado itself is not common, but among the global occurrence of tornado, if you ask me which region tornado occurrence is very, very common, it is this region, right? So all this region put together, we call them as what? Tornado Alley. Okay, right. Right, my friends. Everything about tornadoes also we have just taken it. And tornadoes in North America, particularly in USA, how exactly locally it is called as? What is the local name of tornado in USA? It is called as what? Twisters. Okay. And that was the question that is asked this year. In North America, tornadoes are called as twisters. So here you can find, when we talk about this tornado alley, right? States like Kansas, Texas, etc. Only Texas you take it. And forget about this region, right? But what I understand again, here three types of air mass is mixing. What are the three types of air mass which is mixing? Cold and dry air mass. Cold and dry air mass is nothing but what? Continental, polar. What is this warm and dry air mass? Continental, tropical. What is this warm and moist air mass? Maritime, tropical. So that's the reason I said, whenever this all three air masses mix with each other, that's a place where it may result in the formation of what? Tornadoes, right? Sometimes you also call them as what? Twisters. Okay. So how exactly tornadoes will look like, right? It almost looks like a miniature of what? The tropical cyclonic circulation, right? Almost you will be having a funnel-like structure which almost connects the tropopause level to the surface. And it will be having a violent spiraling rise. Okay. So normally what happens, wherever it is occurring or wherever this twisters or tornadoes is passing, right? Almost any objects will be removed and the same will be raised in the atmosphere. Okay. They are very, very violent and generally they are short-lived, right? Sometimes what happens, only for a few hours it will be almost having its presence. Okay. Right. We talked about tornado. And again, I have just given you alternate name for tornado. What is the name? You call them as what? Twisters. Okay. Now, sometimes what happens, the miniature of tornadoes or twisters takes place, right? If at all, if the miniature, the velocity or the intensity may not be so great, if at all, if such miniature is taking place in the land, we call them as what? Whirlwind. We call them as what? Whirlwind. Okay. See this whirlwind. Sometimes what happens as a kid, if you're playing in some, say, for example, hot days in the ground, right? Sandy ground, muddy grounds, right? We ourselves would have experienced what? This whirlwind. Am I right? Somewhere along a common center of depression, right? You'll be finding a violent circulation is taking place, right? This you call them as a miniature of tornadoes. Mechanism is same. You call them as what? Whirlwind. R is silent. Okay. You call them as what? Whirlwind. Or whirlwind, whatever it is. Somewhere note down these terminologies, right? Such as whirlwind. Okay. If at all, if it is happening in the land, the miniature of tornadoes, you call them as what? Whirlwind, right? The same thing if it is happening in water, oceanic region, we call them as what? Water spout. Same thing what happens in the oceanic region, we call them as what? Water spout. Okay. So normally in water spout, what can happen? The same mechanism, but when it is rising, right? Somewhere along with the rise, water will be taken along with it, and the same water will be precipitating somewhere else. Have you ever seen a video or in a social media that say, for example, fish will be falling from the clouds, right? Now comes the question, how come it is possible? How it is even possible? Fish falling from the clouds. You're saying fish after death will be going up. The soul of the fish will be going to the, not the soul. Okay. Simple answer is very simple. When I just talk about the so-called the fish rain, it is possible only with this water spout as a mechanism. Okay. Otherwise, say for example, wind is not so strong to take the fish as such. So what happens during this normally occurrence, right? When the rise of this water is very, very strong, right? Along this spiraling effect, physically water will be somewhere taken up. Along with this water, the fish will also be taken, right? Assuming that they are not so big as a fish, okay. And then and there itself, when the convection becomes weak, the fish will be falling, right? Very nearby areas, it will be falling, okay, right? So water spout also I have just given you, right? Mechanism happening in the land, that also I have given you. You call them as what? Whirlwind. Okay. So that's all about temperate cyclonic circulation. Okay. So this is the question that is asked this year. What is a twister? What are the majority? Okay, why are the majority of twisters observed in the area around the Gulf of Mexico? This is what you have to write it. Maybe you take it as a practice question. Write an answer for 250 words. Now tell me, what should be the structure of this answer? Number one, divide the question, look for how many questions are lying within the question. 2 questions are there. Number one, first, I have to talk about twisters. So what is a twister? The first and foremost, you have to establish that twister is the other name of tornado. Then I have to define tornado. What is tornado? Very simple. Twisters are called as tornadoes. Okay. Simple. Intensified temperate cyclonic circulation, you call them as what? Tornadoes. Okay. One small clarification. Some of the books, even net sources, says tornado is more like a tropical cyclone, right? I'm not denying this fact, but actually speaking, tornado can neither be classified as temperate cyclones, nor it can be classified as what? Tropical cyclones. But which cyclonic circulation, if it is very close, if you ask me, this mechanism is very close to what? Temperate cyclonic circulation. Why I'm telling you? Because temperate cyclonic circulation is resulted because of confluence of 2 contrasting air mass, right? What are the 2 contrasting air mass? One is continental polar air mass and another is what? Maritime tropical air mass. Here, tornado, one more air mass is added, right? What is that air mass? One more air mass is added. That is continental tropical air mass is also what? Added. So that's the reason we say this mechanism is more close to what? Temperate cyclonic circulation. Okay, somewhere I'm talking about intensified temperate cyclonic circulation. And what else I should write? What is the precondition for the formation of tornadoes? Squall line. I have to talk about what? Squall line. Okay, somewhere. Because I understand, right? Sometimes squall line can get transformed into what? Tornado. Somewhere I told you, temperate cyclonic circulation may develop a squall line very rarely, and squall line very rarely gets transformed into what? Tornadoes. Okay, so I have to mention about squall line. If I can define squall line and the weather effectivity associated with it, I can go for it. Okay, right. That is what I have to talk about what? Tornadoes. Then comes the question, why majority of twisters observed in the area around the Gulf of Mexico region? Number one, maybe technically, if I'm not able to answer that question, somewhere I have to talk about what? This region called as what? Tornado alley, right? Tornado alley. It's more like a friend of tornado, something like that. Tornado alley. Okay. Then again, I can say the Gulf of Mexico, say for example, comparatively a larger sea region where the supply of maritime tropical air mass is also great. And cold polar wind coming from the Canadian region is also very, very strong in this region. And that's the reason, right? Somewhere I understand this region is known for what? More of tornadoes. Okay. So kindly take this question, write an answer to this question. Even yesterday also.
Veranda IAS, where your dream becomes reality.